Today we're going to talk about segments, so line segments and stuff. So last lesson we learned how to write different notations for different things. So this lesson we're going to be focusing on line segments. So before we get into this theorem, we're going to go ahead and look at this number line. Okay, A is on -2, B is on 1, C is on 3. So find find BC. So from B to C, how long is that? This is 1, this is 3, right? So this is 2. So it's 3 minus 1, which is 2. And what is AC? So from A to C is -2 to 3. So if you count, this will be 1, 2, 3, 4, 5, right? This is 5. If you're going to use subtraction, you're going to do 3 minus -2. So you do the right side coordinate minus the left side coordinate, which is 5. So either way, this is 5. In this picture here, we're finding xy. X is on 1 and 1/2. Okay, 1.5, so it'll be 1.5. Y is on 5. So this will be, if you count, this will be half, right? So 1.5, 2.5, 3.5. If you're gonna use subtraction, that will be 5 minus 1.5. So that'll be 5 minus 1.5. That gives us 3.5. So this is 3.5. X to Z. XZ, because this one's going backwards. Because if you get a negative number and you don't get a negative number, XZ and ZX mean the same thing, okay? XZ, ZX, XZ means the distance. So if you're gonna see like a little bit different notation, like this one doesn't have the bar. Doesn't have the bar means the distance. If it has the bar, that means the segment itself, okay? Well, I think we'll go over this one in class, the difference between different notation. So XZ and ZX, doesn't matter it's XZ or ZX, they mean the same thing. They mean the distance from Z to X. Okay, how long is it? So you have 1, 2, 3, 4, 4.5. So you're gonna use subtraction, you're gonna have 1.5 minus -3, which is plus, so you get 4.5 either way. Okay, the segment addition postulate. Postulate is just like a theorem. Okay, postulate is something like we just take for granted. We don't prove this. That's the only difference between a postulate and a theorem. Theorem, we usually prove it and then before we use it. For postulate, we don't prove, we just take it and use it. For example, this one, what is a segment addition postulate? This one says is if B is between A and C, B is between A and C, then AB plus BC is equal to AC. What they're saying is if AB is 2, BC is 5, AC is what? 7. You add them together equals to that big one, right? This is obvious. 2 plus 5 is 7. So this is something we use. We don't prove. You really can't prove this, right? How do you prove 2 plus 5 is 7? Well, you just gotta add them and get a longer one. So this is a segment addition. In geometry, a lot of times you have to draw a picture if there isn't one. If you don't draw a picture, it's really hard to visualize and find the answer. So this one, I'm gonna go and draw a picture. G is between F and H. So you're gonna have your picture, okay? And G is between F and H. So this is F and H. G is between. Between does not mean right in the middle, okay? Between somewhere, okay? Somewhere in between. Does not mean right in the middle. It says FG is 6. FH, okay, FH is the whole thing, okay? So from F to H, this whole thing, I'm gonna change it to a different color. So from F to H, this whole thing is 11. Find GH. Okay, so this is 6 plus which number is 11? 5, right? So GH is 11 minus 6 is equal to 5. This is like directly using the segment addition postulate, just like finding segments. You either add or subtract. Next one, y is between X and Z. So this is X, this is Z, right? Y is between, gonna be somewhere in between. Let's say XY, let's say Y is right here. Okay, XY is 1 1/3. XZ is 3. So this whole thing is 3. What is YZ? This is again, we'll have to subtract them to find that one. YZ is equal to 3 minus 1 1/3, which is 1 2/3. Next one we don't have numbers, we have variables here. DE is 3x minus 1, EF is 13, the total is 6x. So the segment addition says DE, the length of DE plus the length of EF is equal to the length of DF, right? So this one and this one is equal to this one. So I'm gonna go ahead and put it in. What's DE? DE is 3x minus 1 plus EF is 13 is equal to DF is 6x. So the two short ones add together equals the long one. Then you need to solve the equation. Negative 1 plus 13 is 12. This is equal to 6x. So I'm going to go ahead and subtract 3x. So 12 is equal to 3x divided by 3. X is equal to 4. So x is equal to 4. So do you think we're finished? You're almost finished, right? You found x is 4, but you need to find df. What is df? df is 6x, right? df is 6x. You're going to plug the 4 into the x. So it'll be 6 times x. X is 4. 6 times 4 is 24. We remember to plug in to find the final answer. Next one. M is between N and O. Okay, you can see from the picture, M is 17, MO is 3x minus 5, and NO is 5x plus 2. So same thing again. So if you add the two short ones equals the long one. So N M plus MO is equal to NO. NM is 17, MO is 3x minus 5, NO is 5x plus 2. Okay, I'm going to go and combine them. So 17 minus 5 is 12. 12 plus 3x is equal to 5x plus 2. Okay, that's why we spend a lot of time solving equations before getting to this. If you don't know how to solve an equation, this is going to be hard to find. And so minus 3x minus 2. So 10, it's not 10. This is 10 is equal to 2x, so x is equal to 5. So x is equal to 5, and we need to find NO. So NO is equal to the whole thing, right? 5x plus 2. So 5 times x plus 2, x is 5. So 5 times 5 is 25, plus 2 is 27, NO is 27. If you put a 5 into this one, 3 times 5 is 15. 15 minus 5 is 10. So this one is 10. So this is 17, this is 10, this is 27 perfectly. So it means you got the answer right. I think we're just going to go ahead and skip this one. I think we did 2 examples is good enough. And one more thing we're going to cover in this lesson is a midpoint. So what happens if you have a segment, let's say you have A and B, and then you have something right in the middle. Okay, it's called a midpoint. So let's say this one is M. So what does that mean? What does a midpoint mean? Midpoint means right in the middle. That tells me AM is equal to BM. AM and MB are the same. So these two segments are congruent. Okay, so this one AM is congruent to BM. That's what midpoint means. Bisect is a new vocab, means cut something in half. Okay, cutting something in half. If I have a segment AB, I'm gonna have a line come in, cut the segment running half. So you have a line come in. Okay, the line doesn't matter which way it goes. So this line cuts, let's say this is line T. Line T cuts segment AB in half. That means this one is right in the middle of AB. That means this one and this one are the same. Okay, bisect means cutting in half. This is a verb. Cutting in half is bisect. Let's go on and look at this question here regarding midpoint. The map shows the route for a race. You're at X, 6,000 feet away from the first checkpoint C. So you're at X, you're 6,000 feet away from C. The second checkpoint D is located at the midpoint between C and y. So D is in the midpoint of C and y. So that means CD. Okay, so this means D is in the midpoint between C and Y, means CD and YD or DY are the same. Okay, the total race is 3 miles. How far apart are the two checkpoints? So first of all, we have feet and the miles. So we're going to convert the miles into feet. 3 miles is how many feet? How many feet in 1 mile? 5,280 is one mile, has these many feet. Okay, you have 3 miles, you gotta times by 3. So you get 15,840 feet. So this together is 15,840 feet. So they're asking how far apart are the two checkpoints. So the two checkpoints, one is C, one is D, asking for how far apart is C from D. So this one is actually, if you look at the picture here, total is 15,840. If you take away 6,000, so that would be what? 9,840 feet. So this one is, you take away 6,000, that will be from C to Y. C to Y is this number, and D is right in the middle. So how far is CD? Half of that, right? So do this number divided by 2. So that will be 4,920 feet. Okay, this gives an answer to how far apart are the two checkpoints, which means C to D. So let's do a couple more examples here. D is the midpoint of EF. Okay, this is given. D is right in the middle. That means ED and the FD are the same. ED is 4x plus 6. FD is 7x minus 9. We're going to find these 3 segments. This one you're going to say, okay, I'm going to add them together equal the whole thing. But we don't know the whole thing. The whole thing is not given. But the midpoint means they're equal. Okay, ED is equal to DF. This one, just let them equal. This one, we're not adding them because we don't know the total, right? So 4x plus 6 is equal to 7x minus 9. And then we're going to go and solve this equation. I'm going to minus 4x plus 9. So 15 is equal to 3x divided by 3x is equal to 5. We're going to find ED. 4, plug it in, 4 times 5 plus 6, that's 20, so 26. And DF, 7 times x, 7 times 5 minus 9. 7 times 5 is 35. 35 minus 9 is 26. You see these two are both 26 because they are congruent, right? They're the same, they're congruent. So D is the midpoint. So we're going to go ahead and find last one is EF. Okay, EF is 26 plus 26, which is 52. The total is 52. Next one, LH bisects segment GK and M. So this one, bisect means cut in half. Okay, cut in half. So LH cut GK in half, not the other way around. Okay, so LH is this one, cut GK in half. So GK is cut in half. M is the midpoint. So that means GM and the KM are the same. Okay, so these two segments are congruent. GM is 2x plus 6 and GK is 24. So GK is 24. The whole thing is 24. If you look at this one, like, okay, M is in the middle and is the midpoint. GK is 24, so each one has to be half of 24. Each one is 12, right? So each one is 12. That means 2x plus 6 is equal to 12. This one is equal to 12. Or you can have a different equation. If you're going to use the segment addition, that will be 2x plus 6. That's this one. And plus MK. MK is 12 equal to the total. That is 24. This equation is also okay. Both the equations are right. Whatever one you prefer. I think this one's a lot easier. So subtract 6. 2x is equal to 6 divided by 2. x is equal to 3. If you solve this equation, you're going to still get 3. So find x, we did. X is equal to 3. Okay, last example, we're done. M is the midpoint of segment AB. So we're going to have a segment AB. M is the midpoint. Midpoint means AM and BM are congruent. Let's see what is given. AM is 2x minus 1. AB is the whole thing. The whole thing is 16. So what is BM? Find BM. Well, this one's pretty much the same as the previous one, right? If the whole thing is 16, each one is going to be 8. This one is 8, and this one is 8, right? Each one, 8 plus 8 is 16, so the equation is 2x minus 1 is equal to 8. So x is equal to 4.5, right? If it's plus 1, you get 9. 9 divided by 2 is 4.5. So BM is just 8. Okay, I think I'm going to go over one more. Okay, this is not the one I thought it would be. Okay, so this one, y is the midpoint of xz. So x here, z here. Y is the midpoint. That means x1 and y0 are the same. These two are the same. This is the midpoint. xy is 2x plus 3. xz is 6x minus 4. Okay, this is the one I want to go over. Okay, you're going to say, okay, this is the midpoint. This is not a number. So what do I do? So the midpoint, some guys might think, okay, this is not given, so this must be x. I'm going to do 2x plus 3 plus x is equal to 6x minus 4. Is that right? And this is not right, because why do you put x there? How do you know that's x? You can't just put x on any blank spot, right? But you're going to use your midpoint. If this is 2x plus 3, this is the same thing. It's also 2x plus 3, right? They are the same, so you add them equal to long one. So 2x plus 3 plus 2x plus 3 is equal to 6x minus 4. Combine like terms, that'll be 4x plus 6 is equal to 6x minus 4. And solve the equation. Okay, this is pretty easy. So 10 is equal to 2x, so that means x is equal to 10 divided by 2 is 5. I'm going to go and find xz. xz is 6 times x minus 4, plug it in. 6 times 5 minus 4, that's 30. Minus 4 is 26, so xz is equal to 26. Okay, this is all.